Oh wait, are we ready to start? Cool, thank you guys for joining. My name is Don Barnetson. I'm from Credo, and I'm here to represent the Rack and Power Experience Center booth, which I think might have been the busiest booth on the show floor yesterday, hence my deep baritone voice today. We've got quite a few participating companies with us. Aorus, obviously Credo, DriveNets, Flax, Hyster, JTech, Meta sponsored 3 of the pieces, nVent, Pape, Rittal, UfiSpace, and WeWin. Quick message from my legal department, make sure that you're seeing that. So the reason we put this booth together is AI is challenging data center infrastructure. We're moving power densities up very, very rapidly from traditionally maybe 8 to 12 kilowatts per rack up towards 50 kilowatts per rack or more. This is having a massive impact on serviceability. Network densities are also moving up massively. So previously we perhaps had 1 to 2 terabits per rack in a single front-end network. Now we're adding another 10 to 40 terabits per rack in a back-end network. So power densities are maybe tripling, network densities are going up by a factor of up to 20x in this case. And this back-end network is really complicated. It's much more sensitive to latency and jitter, and it needs to be absolutely lossless. They're very close to lossless in this space, dominated by elephant flows and very limited entropy to do ECMP and other functions. So if we take a look at the booth, we've got exhibits that cover all of this. Starting on the left-hand side, there's 3 exhibits that were sponsored by Meta. Meta has their liquid-cooled blind mate rack where you can slide a server directly in. It makes contact with the liquid on the back, automatically bleeds itself, and goes to production. Super cool. Next to it, they have a liquid cooling servicing cart with a heat exchanger on the back of the rack. Definitely take a look at that. And then we have the automated tug in the corner, which is a tool that Meta uses to pull racks around their data center in order to move them in and out efficiently. Very cool. On the right-hand side, Flax is showing some heat reuse use cases, as well as equipment reuse, which is super cool. WeWin has a liquid cooling demo as well, which I'd encourage you to look at. And then UfiSpace is showing some of their equipment right next to it. Across the back, which is closest to my heart, we've built up a mock-up of an entire data center for you as kind of a thought piece. So if you look at this, it's broken into 9 racks. On the left-hand side, we have general compute. On the right-hand side, we have AI, ML, and in the center, we have spine and routing layer. Inside of each of those, we have a 2024 look. Essentially, what does it look like today? We have a leaf rack in the middle, and then we have a thought piece, a 2027 look. How are things going to evolve in 3 years in this space, both on the general compute, the AI, as well as the spine? And so on the general compute, we believe there's a need to go to CXL as the rack scale interconnect rather than Ethernet to facilitate memory sharing, to facilitate centralization of the DPU resource, which is very expensive, and to enable the bandwidth that's going to be necessary here. So we'd be happy to walk you through and talk to that in more detail. On the AI side, we have an Intel Gaudi 2 that's powered by a backend network running Ethernet over a large buffer switch today, a Jericho 2C Plus switch with a Ramon backend. That's a great solution today. It's guaranteed to be lossless. However, it's relatively high latency in single-digit microseconds, and it's relatively expensive. So on the right-hand side of the AI section, we go to a backend that's, again, powered by CXL. In this case, though, actually attached to a full row-scale CXL leaf network, which allows us to extend that across perhaps 20 or 40 racks of equipment to enable very high bandwidth, and perhaps if you saw my talk yesterday, most importantly, power efficiency. So we can get lossless performance, we can get about an order of magnitude latency reduction compared to the large buffer switches, and then we can get power scaling. So within tens of microseconds, you can shut this down to about 15% of its operational power, all the way from the user space of your application, not having to go through some out-of-band control plane that's going to be much, much too slow to enable this. In support of this, Credo announced the Highwire CXL Consortium at the show yesterday. The Highwire CXL Consortium is dedicated to the standardization of CXL active electrical cables and optics. Those of you who are familiar with Highwire may note that 4 years ago we launched this in the Ethernet space, and the Highwire active electrical cables became the backbone of active electrical cables that many of the hyperscalers run their networks on today. We're pleased to work with a similar group of companies to standardize the CXL consortium. There's more information at highwire.org. Please take a look there, or please come find me and talk about it. We would love more thoughts and participation. There's so much activity going on in the PCI Express CXL space. It's important to get everybody's views there. Last piece that I think is really interesting is the Highwire pluggable patch panel. We installed that actually at the center of our routing rack. So this is the first patch panel that's ever been developed actually for pluggables. Historically, patch panels were a passive device that you'd use for copper, or perhaps you'd use for optical. In this case, what we allow you to do is, if you have a standard switch, perhaps that has 400 gig ports or maybe even 800 gig ports, you want to plug in high power optics, but your switch doesn't have software support for them or doesn't have power and cooling for them, you can use an active electrical cable to remote that up to another very simple box, and then that box will provide power and cooling and control for your high power coherent optics. Or perhaps you have a speed mismatch. Perhaps you have a 400 gig switch and you want to use 100 gig coherent optics. We can give you a breakout cable that'll do the 4-to-1 breakout. It'll do the gearboxing functionality inside the cable. And then you can plug in your 100 gig optics without throwing away the radix on this. Additionally, if you're using EDFA amplifiers in order to push your fiber even farther, it gives you a great place to plug those into that doesn't spend very, very expensive switch and routing ports. So I'd encourage you to take a look at that in the Experience Center, and then also come to the Credo booth where we're demonstrating that live. So a very simple call to action. Come, talk to us. There's 15 companies participating in our booth over there. We would all love to engage with you. Liquid cooling is going to be extremely important to us, as is recertification and heat reuse, autonomous maintenance, and then what's closest to my heart is the future of interconnect. 5 to 20 times as dense as what we've been doing in the past, and it really throws out the playbook on what we've been doing and creates an enormous opportunity for all of us to solve the problems that our collective customers have. Thank you so much, and enjoy the show. Cheers.